So this is 6-1 alpha. We're dealing with discrete and continuous random variables. So what do those words mean? If it is discrete, the easiest way to communicate that is for you to turn around and look at the clock. And if you look at the clock and you look at the second hand, that second hand is not sweeping. It pauses between each second. It's discrete. So discrete is, ready? How many people were on the bus this morning? Well, there were 20 kids on the bus. Were there 25 kids on the bus? There wasn't 22 and a half kids on the bus. So there's an integer value of people on the bus. That's discrete. Continuous would be if you count the values in between the integers. So we're going to focus on discrete. The outputs are whole numbers. And then one way to do it is a histogram. We want to describe the shape of the histogram. We talked about these would be univariate data. When we describe univariate data, we talk about center, shape, and spread, the variability. And then the center, so this is the shape, here's the center. The mean is a weighted mean. We'll go over an example of what that's like, okay? So what's going to happen is we're just going to go to 3 questions, 3, 5, and 11. All right, so let's take a look at what's happening here. For number 3, it says, they give you the table, which is reproduced on the PDF. Find the probability of less than 20. Well, I can find the probability of at least 20. Because that's a shorter calculation. And just add them up and subtract it from 1. So here's 20. Less than 20 would be the sum of the first 4 elements in this column. What leads you to B? What's the probability of at least greater than or equal to 20? The sum of those two. So it's a complete set. The whole thing has to add up to 1. So if we do B first, we get 69%, and A would have to be 1, take away that, or 31%. Then problem 5 asks you to draw a histogram. Now, your calculator doesn't work this way for a histogram. So I drew it like this. But essentially, these would be boxed off. That make sense? That's what your picture should look like. That's a histogram. So they ask you to describe this. Well, the data is primarily to the right, and for the shape, the skewness refers to the tail. So it's skewed left, because the data is primarily to the right, the tail's to the left, and skewness describes the direction of the tail. And for 11, so what I did was I did 1 variable statistics to the data that's already in there. So let's make sure we can all do that. So take out your calculator. And we're going to put the table on page 375 into 2 lists. But we're going to load list one a little differently than just typing the values in, because you see what you have. You have this, you have the values going from 0 to 25, where the double list is 5. And if that were a really long list, we want to know how to do this without typing them all from scratch. So we're here on the calculator. Second stat ops. We want to type the sequence, which is choice 5. Now, if you have the older calculator, these commands are what you type in, you're just not getting the prompts. So if you have an older 84, you would type in x, comma, 0, comma, 25, comma, 5. Close parentheses. If you have the newer one, it's telling you what you want. So I scroll down here where it says paste. That's what it'll look like if you have the older, ready? If you have the older TI 84, then that would be your command. Your argument, we want to do with that, we want to store this, we want to send this, store above the on key to second 1. Now, you could have typed these values in there in that amount of time, but if this list went up to 7 from 0 to 75, this would be way more efficient. You need to be aware of how this works. So I go here, stat, edit, and then list 2 you have to type in manually, and list 2 is the corresponding probability for that, for collecting that amount of money. That's in the bottom row on page 375. Now, we want to make sure you make a typo. Second quit, second stat, over to math, 5. What's the sum of list 2? Yeah, it better be 1, because if you have a typo though and it's not 1, that's going to throw off your calculation. So 1 is meaning we've accounted for all the possible outcomes. When this guy runs his furry, he knows he's going to come home with between $0 and $25. He's not going to get $22. He's not going to get $50. That's the complete set. So now we go here. Second stat. What is the sum, 5, of list 1 times list 2? Because that's the weighted average. Now think about what this is doing. This is saying 0 times 2%. 2% of the time you collect $0. Plus 5 times 5%. Because 5% of the time you collect $5. So this is the sum of the product of the 2 lists. And there's the amount, which in the textbook, they gave you, if you look at problem 11, the mean is $19.35. That's how they got that. That's one way of getting it. Or we could do this. Stat, calc, 1 variable statistics. The only thing that's varying is the amount of money he brings home. So we type 1, And our frequency list is list 2. And we get all this data, ready? Now, you see this down arrow? This is telling you there's a second page to the data. So there's the mean, which you already got. Okay? There's some things we don't need. If you notice this is the standard sample standard deviation with the Roman letter S of X. It's empty. The reason this line is empty is because list 2 sum to 1. So the calculator knows that you have 100% of the data set. So there's a population step, but no sample step. And we scroll to the second page. Here's the median, which is $20. The median is higher than the mean, which makes sense because the mean is sensitive to outliers. So it's sensitive to the skewness. And the lesser amounts of the tail affects the mean more than it affects the median. Okay. So here's the graph length of the resulting thing we just showed you. But then we're comparing. Here's X bar, that's the mean. There's the median. The median is higher because the mean was affected by him collecting $0 or collecting $5, which drags the mean down. Okay. So that is it for the alpha lesson.